What's up, kids? Today we are continuing on with trig identities, and this video is about the sum and difference formulas and how you can use them to do a few different things, not just the same type of problem. So I've got three different problems here of how you could use these formulas. And notice number one, right off the bat, trying to evaluate something like that, the cosine of 19 pi over 12, that's not a unit circle value. So that's where you might use one of these identities to break it down into something doable. So just notice these formulas here, the way they're presented, as you may see in your textbooks or on any reference sheets, these three formulas are really representing six formulas: the sine and cosine and tangent, sum and difference. It's just all kind of compiled as one. Notice the plus or minus. So the symbols correspond, though, that everything on top corresponds on top. And what I mean by that is if you're talking about the sine of two angles added together, u plus v, then the formula is sine u cosine v plus cosine u sine v. If you're doing a difference, sine of u minus v, then you have to use, notice that's the bottom as it's written, then you have to use the difference here in the formula. So you can't just willy-nilly use a plus and then a minus, whatever you might like. And notice that in the cosine formula, the cosine, when you're doing a sum of u plus v, notice what's on top here. It's written minus plus, and that shows if you're doing a sum, then you have to use a difference here. Or conversely, if you're using a minus, a difference, then you have to use a sum here in the formula. So that's just a little something to watch out for. Don't get tripped up by that. Just be careful. Tangent, notice they're all over the place, but if you're doing tangent of u plus v, using the top symbol, then you got to use the top symbol in each of these plus minus expressions here. So use a plus right there, but in the bottom, 1 minus plus means, I got a little messed up there, they got to use the minus there. That's what's on top. Or if you're doing a difference, u minus v, then you got to use the bottom symbol. So in the numerator, you would use minus, but in the denominator, you would use the, why is that doing that? There we go. You would do a plus. Okay. You get the idea, my bootleg tech here. So here we go. Let's just jump in and do some problems here. So a few things, actually. Cosine of negative 19 pi over 12. The idea is that if this is not a nice unit circle value that you're used to doing, then you could try to break it up into the sum or difference of two nice unit circle values. And that's the goal. Try to break it down into two angles. That's the sum or difference that you know how to deal with. So you're looking for pi over 6s, pi over 3s, pi over 4s, pi over 2s. And that negative, you can certainly find two angles that add or subtract to be a negative. But this is a nice little thing to remember is your odd and even identities. And remember, all trig functions are odd or even. Cosine is an even function, meaning that cosine of negative x is always equal to cosine of x. That's what an even function is, right? F of negative x equals f of x, symmetric over the y-axis, which cosine is. So when you see this, cosine of negative 19 pi over 12, if you feel like that negative is going to add, one little bit of annoyance, use your odd-even identities and say, well, that's the same thing as just doing cosine of positive 19 pi over 12, and just go from there. If it was a sine or a tangent, which are odd, then you would write the negative on the outside, right, to take the opposite of the sine or tangent. So now let's go from here, actually get into using these. And like I said, you're trying to break it down into those classic denominators, pi over 6, pi over 4, pi over 3. When you're doing these, one of them will almost always be a pi over 4. So just think about that with these. I always start with the pi over 4 and think about what pi over 4 is in terms of the denominator you're dealing with, which is 12. So pi over 4 is equal to 3 pi over 12, right? So This 19 pi over 12 could be thought of as 3 pi over 12, which is really just pi over 4, plus what else? And so what else would have to make that up would be 16 pi over 12. 19 pi over 12 is 3 pi over 12 plus 16 pi over 12, which each of those reduces. 3 pi over 12 is pi over 4, of course. That's what we used. And 16 pi over 12 reduces, we divide each by 4, to 4 pi over 3, which is another nice unit circle value. So pi over 4 and 4 pi over 3. And it's not the only combination you could do, but it's definitely one. So I'm going to break this 19 pi over 12. I'm going to, try to write this out, the first, the example we're doing here. Just going to try to think of this 19 pi over 12 as pi over 4 plus 4 pi over 3 on the inside there. And so now those are your u and v values in this formula. So I'm doing a cosine sum. Cosine sum, which means when I break it up, I've got to use the difference here. So, and u is pi over 4 and v is 4 pi over 3. So just follow the formula. And so this will be, according to that formula, cosine of pi over 4 times cosine of 4 pi over 3. And as we said, that's going to be a minus sine of pi over 4 sine of 4 pi over 3. That's how the cosine sum difference always goes. Cos, sine, sine, with the opposite sign in the middle. And now just evaluate these straight off the unit circle. So cosine of pi over 4 is root 2 over 2. Cosine of 4 pi over 3 is negative, because that's in quadrant 3. And only tangent's positive there. And the cosine of any pi over 3 is going to be 1/2. So this is negative 1/2 minus the sine of pi over 4, which is root 2 over 2, times sine of 4 pi over 3, which is, again, quadrant 3, where sine and cosine are both negative. And the sine of 4 pi over 3, or any multiple of pi over 3, is the ratio root 3 over 2. So that's negative root 3 over 2. Multiply, combine. So we get negative root 2 over 4 when we multiply those two fractions. The second group, negative root 2 over 2 times negative root 3 over 2, will give you positive root 6 over 4. Root 2 times root 3 is root 6. Over 2 times 2 is 4. They have the same denominator of 4, so put them together over that common denominator, right? Just don't mess up the easy algebra at this point. And you get negative root 2 plus root 6 over 4, and you can't add those two radicals because they're not like terms. So we just leave it like that. Some people would prefer to write this, the positive root first and the negative second. It doesn't matter, of course, but you might be more likely to see that written. But there you go, and it's kind of cool to see that, that you get that exact value. If you were to type this into your calculator, you'd get some crazy looking decimal, and that decimal would be the same decimal as if you converted this. So that's a way to check yourself if you like. All right, let's just see a couple other problems here. Like I said, I got 3 different types. So something like this, evaluate this crazy looking fraction, tangent of 7 pi over 12, etc. And so you might take a look and say, hey, I know that one right off the bat. Tangent of pi over 4 is 1. That's right off the unit circle value. So I could make those be 1. And then you just have to deal with that. And that's another pi over 12 kind of denominator. And you'll see those a lot in this unit. So you could do 7 pi over 12 and break that up and use like a tangent sum or difference just to evaluate this piece of it. However, you're missing the big picture if you do that, because you should recognize that this is in this format. So I can actually take this and condense it down. So I'm going to go the other way around, basically what I did in the previous problem. Rather than take a sum difference and use the formula, I'm going to use the formula and go backwards. So you just got to recognize that this is a tangent sum or difference, where the two angles are 7 pi over 12 and pi over 4. Just be careful, what are you doing? Am I adding or subtracting those two? And if you see a minus and a plus here, a minus up top and a plus right here, that means you're using the bottom symbol. That means that is a tangent difference. You know, the top symbol is always the same as what you're doing if you haven't caught that. So if you see a minus up top, that means that's a minus on the inside there. And now here we are again, but let's actually subtract those two things. So 7 pi over 12, I'll leave that, but I will convert pi over 4 to a denominator of 12, and that is 3 pi over 12. Subtract those, so that will give you 4 pi over 12, which reduces to pi over 3. And that should be a very famous, recognizable value. The tangent of pi over 3 is root 3. So this big crazy looking expression is really a pretty simple looking one in disguise. And there you go. And lastly, let's solve an equation. So you take a look at something like this. We're going to solve this equation over that classic interval 0 to 2 pi. So we're going to answer in radians, but only in this interval. And you see this. Notice this cannot be factored. It's kind of crazy looking, but hopefully you would recognize this as one of these sum difference identities, sine cosine minus cosine sine. So sine cosine, cosine sine, that is a sine sum or difference formula. And notice it's got a minus in the middle. So this can be expressed. I'm going to, again, condense this like I did in the previous problem. This is just the sine. Is it sum or is it difference? So just take a good look. If that's a minus there in the middle, that means it's a minus on the inside. It's always the same with a sine. If you see a minus, it's a minus. It's the opposite of the cosine one. So condense that. 7x minus 5x is obviously 2x, and you got yourself a much easier equation to solve. It is one of those multi-angle problems, but that's okay. Sine of 2x equals -1. So going to be a little review of that. So as you may recall with these, you can't divide by 2 yet. You got to take the inverse sine of each side basically and say when does sine equal -1. And that happens at 3 pi over 2. That is the only time the y-coordinate is -1. And that is what 2x must equal, right? The inside must equal 3 pi over 2 for that to work out and be -1. And keep in mind that to find other solutions, you would add 2 pi n, right? However many times you want. But now you have to divide by 2 to solve for x. So you've got to divide that solution by 2, but you also have to divide this 2 pi by 2. And that is adjusting the period, right? That's what happens when you have sine of 2x, is the period is always 2 pi over b, whatever that is. And so you've got to shrink up that period. So this is going to be 3 pi over 4, you take half of 3 pi over 2, and you would add pi, and that's the new period, to get to further solutions. And so we're going to take our 3 pi over 4, that's the first solution, and then add pi to it as many times as you want, and as long as you're within that interval of 0 to 2 pi. So if you add pi, which is adding 4 pi over 4 to make a common denominator if you can't do that in your head. So adding 4 pi over 4 is 7 pi over 4 to that. And if you add it one more time, you're going to be at 11 pi over 4, but that is bigger than 2 pi. So there are only 2 solutions, right? And there was only one solution originally. So 2x should yield 2 solutions. And there we go. So a little review of the multi-angle kinds of problems, but in the context of how you can use these sum and difference identities to sometimes make a simpler equation to solve. So there we go. 3 different problems, and hopefully you feel a bit better about them. If you got any questions, let me know. Otherwise, keep working hard.